Another important application of CNNs is pose or action detection. Deep pose is one of the major work to estimate the pose in an image. Deep pose captures the full context of each body joint by taking the whole image as input. In previous works, the expressiveness was limited, notably due to the use of local detectors able to detect only parts of the body, and algorithms modeled a small subset of all interactions between body parts. Predicting the body joints is just a regression problem in which the image is taken as input in order to predict a vector of size 2k, where k is a number of body joints. To do so, Deep Pose uses a cascade of 7 layers, each one taking a zoomed-in version of the previous image as input, which is nothing but a refinement of the prediction at each stage. More precisely, Deep Pose starts with the whole normalized input image on the left. A CNN composed of 7 layers is applied on this image to produce a vector of size 2k. Then, cropped images centered on the joints are considered. These new smaller images are taken as input of a CNN with the same architecture, 7 layers, as the one before. These networks estimate the position of the body joints, and some cropped images are again extracted and fed to a similar CNN. This process can be repeated several times until convergence and results in more precise estimation than a single CNN. The body joints are displayed here for 3 different images. The predicted poses are in red and the ground truth is in green. The first stage corresponds to deep pose with a single CNN. The second stage corresponds to the predictions produced by a cascade of 2 CNNs, and so on. If you look, for example, at the images in the last row, you see a tremendous improvement between the first stage and the last one. It is unclear whether adding a third stage is really useful here. More examples can be found here in which colors are associated to each body part. Another problem related to pose estimation is action recognition, which aims at classifying human activities based on the visual appearance and motion dynamics. In the fundamental paper of VGGNet, the authors use the outputs of the penultimate layer of a pre-trained CNN to predict actions and achieve a high level of performance in action classification. In this other paper, the authors add a detection part to this framework in order to automatically detect the relevant part of the image in which the action is performed. Let's now see a specific algorithm for action recognition. The input image is displayed on the left. Then you use a RCNN network that we are going to detail later to create a bounding box containing this action. Then, using this red box, you can detect the different body parts based on Poselet, an algorithm close to the one used to detect body joints. You obtain here 4 images that you use as inputs of a CNN to predict the action. Action recognition mixes several tasks as object detection, body parts estimation, and then a more classic classification. In this way, you hope that the network is able to automatically detect where the action occurs in an image, decompose the image into elementary components, and extract information of all components to make a prediction. Here are some examples of action detection. For each action, the images in which the action has been identified by the algorithm are displayed. Here, the set of actions is limited, which leads to good predictive performances.